Welcome to today's video. In our previous video, we've explained resultant force and how to obtain our resultant force. So in this video, we'll be talking about resultant angle. Resultant angle from our previous assignments, from our previous work that we have done. So we'll be calculating the resultant angle from it and how to determine the position of the angle. Sorry for any grammatical error that I might have made in our previous video. I mean grammatical blunder that I might have made in our previous video. That was my first video anyway, so I believe with time there will be an improvement in the video. So now let's move to our today's work, which is our resultant angle. From the question, we have generated our vertical force, which is to be 16.607 Newton. Our horizontal force, 5.4055 Newton, and we have obtained our resultant force, which is 17.446 Newton. 4646 Newton, sorry. So to obtain our angle, as we already know that tan theta equals to sine theta all over cos theta. So our sine theta is the one for our what? Our vertical, while our cos theta is one for our horizontal. That is if we obtain sine theta separately and cos theta separately. After the analysis, we are going to arrive at something like this. So that is why we just go straight to tan theta equals to sin theta over cos theta. As you already know that tan theta is equals to what? Vertical all over horizontal as well. So which is what? 16.607 over 5.4055. So while dividing this, we obtain this. So tan theta is this, then theta equals to arctan of this. Then theta is what? 71.97 degree. Then our theta is 72 degree, or we say 180 degree plus 72 degree, which is equals to 252 degree. So now our main discussion is, why is it like this? From our calculation, we already obtained 72 degree, but we can as well say that our angle is 252 degree, which is 180 degree plus 72 degree. How do we arrive at that? From our four cardinal points here. We have our four cardinal points. So we know we are moving from 0 to 90 to 180 to 270 and to 360, which is back to 0. Now on the first part of the four cardinal points, cos is always positive, sine is always positive, and tan as well is as well positive. On the second part of it, we have our cos to be negative, our sine to be positive, and tan to be negative. Then here, on the third part, we have cos to be negative, we have sine to be negative, and we have tan to be positive. Then on the fourth part, we have our cos to be positive, our sine to be negative, and our tan to be negative. Now, since in our calculations here, the angle we obtain is what? 72 degree, which means that our angle is positive, which means that our tan theta is also what? Positive. And we are now going to check in which position here is tan theta positive. So in the first part, tan theta can be positive, and also in the third part it can also be positive. So that is why here you just say 0 plus whatever angle you have obtained, which is what? 72 plus 0, which means our angle is going to be here, 72 degree, and also here. So we must always refer to the horizontal plane. The horizontal plane. So here, to determine the angle is going to be, since we already passed 180, so it's going to be 180 plus 72 degree. What I mean by it passes 180 is that the angle here, all the trig here, or let me say all the angles here came after 180. Meaning that whatever you are to have here, you must add it to 180, because what we are trying to determine here is tan. We already said tan is positive here, meaning that tan, the angle we obtain, can also lie here. Yes, it lies here also. So meaning that we are going to say whatever angle we obtain plus 180 is going to tell us the position of this, the position where our resultant is going to be. So that is why we are able to obtain 180 degree plus 72 degree. So which means it's going to be in this format. Now let's assume that one of our values here is negative. Let's assume the one on top is negative. Maybe sine is negative and cos is positive. What happens? Definitely our tan is going to be negative anyway, meaning that this place is invalid. Since our angle is negative, this place is also invalid. Then we look for where our tan can be negative, which means our tan is negative here and our tan is negative here, meaning that the angle is going to be in between here and here. And if you don't want to use the tan, you can also use the sine and the cosine, meaning that the sine here is the one that is negative and the cosine is positive. Now let's look at where sine is negative. So sine is negative here, while cosine is positive here, meaning that you can use this place. Using this place for the angle is valid, and also because tan is negative here, this place is also valid. It's always necessary we obtain two results. So, and the result must always be opposite to each other. So to obtain the angle here, assuming it's to be at this point, you know these angles here came before 180. So you are going to say 180 minus whatever angle you have calculated for. So it's going to give us the value of our angle here. And if it is to this point, it's going to be 360 minus whatever angle we have calculated for. It's going to give us the value here. So that is for that. Now let me show you how the angle will look like. So the angle is going to be in this position. On the first part of it, we have 72 degree in this direction, and for the 252, it can also be in this direction. So that is how to calculate for our angles for our resultants. In our next class, we are going to be talking about graphical methods for calculating our resultant force, both the resultant force and the resultant angle. Thank you.